In this video, we are going to finish up this section with one more application of vectors dealing with velocity and speed. So one thing I do want to introduce or recall maybe, in surveying and navigation, a bearing is a direction that measures the acute angle that a path or line of sight makes with a fixed north-south line. In air navigation, bearings are measured in degrees clockwise from north. Okay, so let's take a look at this problem. An airplane is traveling at a fixed altitude with a negligible wind factor, thankfully. The airplane is traveling at a speed of 500 miles per hour with a bearing of 330. Now, remember 330, they said clockwise from north. So 330 would go all the way around to that, right, with 30 degrees. And what they're doing here is they're just trying to get it from standard position. So if it's 330 all the way around, that means that if we just do it from here, like they did with that line, it's only 120 degrees. All right, so we have that. And it says, as the airplane reaches a certain point, it encounters winds with a velocity of 70 miles per hour in the direction of north 45 degrees east. So it's 45 degrees east of north. So if you look at V2 here, V2, if it is 45 degrees, I'm going to draw another picture here just to kind of help us out. Here's V1. V2 goes like this. All right. And then we have our resultant factor, and it makes sense if an airplane is driving or flying, flying along V1 and V2 comes in, it would push it, make it come this way. All right, so we have to figure out, now remember, for forces or any kind of vectors like this, they're wanting the resultant speed and direction. So the resultant speed would be, okay, V equals V1 plus V2 is how we would go about it. The sum of the forces, or the sum of our vectors, is the resultant vector. All right, so all we have to do now is we are going to have to list out the components for each one. So let's do V1 first. So V1, they told us it was going 500 miles per hour, so I know that's the distance. And then we want to come up with each component. Now, looking at the last video, we can use trig and come up with a triangle like that and use this angle. So if we're trying to find the x component, I could use trig to come up with that. Now, the quick way to do that is the x component's always going to be the magnitude cosine of the angle. The angle in this case is 120 degrees. That is my I, always. Then the j is always going to be the magnitude times sine of 120 degrees. It'll always be that way. That's V1. Now V2, I'm going to draw V2, okay, it looked like this. And they said 45 degrees east of north, which means this is also 45 degrees. That sums up my triangle pretty quick. They told that the magnitude of this vector, this is V2, was 70. So V2 is going to be 70 cosine the angle we're looking at, which was 45 degrees. I plus 70 cosine 45 degrees J. All right, working these out, V1, should be really putting arrows over these. V1 is negative 250 I plus 433.013 J. V2, plugging that in the calculator, we get 49.497 I plus 49.497 J. That makes sense. It's right down the middle. So remember, to find V, we add V1 plus V2 using your calculator. Okay, so let's do that. We got negative 200.503. Adding our J components, we got 482.51 J. All right, this is the velocity vector. If I want the speed, okay, remember velocity has a direction and a magnitude. Has to have a direction. Speed just has the magnitude, how fast. 60 miles per hour is a scalar, which is the magnitude in some case of each one. So what I'm trying to say with all that is take the magnitude of that vector to find the speed. Right? If I take the magnitude, that's each part squared. So we'll write that out. Negative 200.503 squared plus 482.51 squared. I sum them, I take the square root, and we get 522.51 miles per hour. And then they also want a speed. Now, here's the deal. Here's V. Let me draw a better one. I have V. And I know that V has different components. V has this for the X component and this for the Y component. So if this is Y and this is X, and maybe I can find this angle. They want the direction, which an angle would be great for a direction. I could use trig to figure that out. This, if tangent of theta, is opposite over adjacent. So maybe I could plug it into that. So tangent of theta, okay, I know y. Y is, where'd it go? 48.251, 48.251 over x, which was negative 200.503. Now we just take the arctan or inverse tan. I'll write this out the way it would show on your calculator. I'm just going to do that out of laziness. So theta is roughly 67.435 degrees. Again, these problems are pretty difficult. It took me a while to get pretty good at them. Some of you guys are going to be natural. Some of you guys are going to struggle. Just keep going, keep trying it. Look for patterns. There are a lot of shortcuts that you can take. For example, the beginning of this, we didn't really draw these triangles to come up with these. We just used the pattern that it was magnitude cosine for I, magnitude sine for J with each angle. All right, so I hope that helps. Happy studying.